The following contains 9 common questions regarding to climate change. What is climate change? The term climate, in its broadest sense, refers to a statistical description of weather and of the related conditions of oceans, land surfaces, and ice sheets. This includes consideration of averages, variability, and extremes. Climate change is an alternation in the pattern of climate over a long time and may be due to a combination of natural and human-induced causes. How has climate changed? Global climate has varied greatly throughout Earth's history. Earth's climate has changed dramatically many times since the planet was formed over 4.5 billion years ago. These changes have been triggered by the changing configuration of continents and oceans, changes in the sun's intensity, variations in the orbit of Earth, and volcanic eruptions. Are human activities causing climate change? Human activities are increasing greenhouse gas concentrations in the atmosphere. This increase is extremely likely to have caused most of the recent observed global warming, with CO2 being the largest contributor. How do we expect climate to evolve in the future? If greenhouse gas emissions continue to grow rapidly, it is expected that by 2100, the global average air temperature over the Earth's surface will warm by around 4 Celsius above mid-19th century temperatures. There are many likely ramifications of this warming. How are extreme events changing? Since the mid-20th century, climate change has resulted in increases in the frequency and intensity of very hot days and decreases in very cold days. How are sea levels changing? Sea levels have risen during the 20th century. The two major contributing factors are the expansion of seawater as it warms and the loss of ice from glaciers. Sea levels are very likely to rise more quickly during the 21st century than the 20th century and will continue to rise for many centuries. What are the impacts of climate change? Climate change has impacts on ecosystems, coastal systems, fire regimes, food and water security, health, infrastructure, and human security. What are the uncertainties and their implications? There is near unanimous agreement among climate scientists that human-caused global warming is real. However, future climate change and its effects are hard to predict accurately or in detail, especially at regional and local levels. What does science say about options to address climate change? Societies, including Australia, face choices about how to respond to the consequences of future climate change. Available strategies include reducing emissions, capturing CO2, adaptation, and geoengineering. These strategies, which can be combined to some extent, carry different levels of environmental risk and different societal consequences. For today's lesson, we will all learn about area. We have a line that has 1 centimeter. Now we move it like a trail and it looks like we made a 1D into a 2D, which as you can see here is just a square. Okay, but how much area does this square have? Well, our original line was 1 centimeter long and we moved it into a distance of 1 centimeter. So we could say that this shape is a square centimeter. A centimeter is a basic unit for measuring length. A square centimeter is a basic unit for measurement of the area. But there are other units for the area too. Instead of a centimeter, what if our line had been a meter long? And then we moved it 1 meter? The area we had gotten would be 1 square meter. Or what if it was a mile long and we moved it a mile? We'd have a square mile of area. So, just like the perimeter, the units of measurement are very important when we were talking about the area. Alright, so that gives us a good idea of what area is. But how do we calculate area mathematically? Well, there are some special math formulas, or also known as equations, that we can use to find the area of different shapes. In this lesson, we're going to discuss the formula for squares and rectangles and also for the formula of triangles. To find the area of any square or rectangle, all we have to do is multiply its two side dimensions together. They're usually called the length and the width. So the formula looks like this. Area equals length times width. But it's often written with just the first letters of each word as abbreviations, like A for area, L for length, and W for width. So let's see if that formula works for our original square centimeter. If we multiply the length, 1 centimeter, times the width, which is also 1 centimeter, what do we get? Well, 1 times 1 is just 1. But how about centimeter times centimeter? Centimeter times centimeter just gives us square centimeters, which we can write like this using a 2 as an exponent. We read this as centimeter squared, and it's just a shorter way of writing centimeter times centimeter. So when you ever see units like those, or inches squared, or meter squared, or mile squared, you know it's a measurement of the two-dimensional quantity area. Okay, our formula worked for our square. Now let's see if it works for a rectangle. Here's a rectangle that's 4 centimeters wide and 2 centimeters long or tall. First, we plug the length and width into our formula. Then we just multiply. 2 times 4 equals 8. And centimeter times centimeter is centimeter squared. So according to our formula, the area of this rectangle is 8 centimeters squared. And we can see that's correct if we bring back our original square centimeter. If we make copies of it, we can see that exactly 8 of those square centimeters would be the same area as this rectangle. Great! Let's try our formula on one more rectangle. This rectangle is 2 centimeters long but only half a centimeter wide. And our formula, which is area equals length times width, tells us that we need to multiply those two sides together to get our area.
2 times 1/2 equals 1. So this rectangle is also 1 square centimeter. But how can it be a square centimeter when it's not even a square? Oh, but just because a shape takes up 1 square centimeter of area, that doesn't mean it has to be a square shape. It just means that the total area would be equal or the same as a square centimeter, like shown. You can see that if we break the rectangle in half and rearrange it, then it would form a square. We can use square units like square centimeters to measure any area, no matter what the shape is. It could be a rectangle, a triangle, a circle, or any other two-dimensional shape. Okay, now we know how to find the area of any square or rectangle using our formula. But we're going to learn the formula for finding the area of any triangle. But to do that, we're going to start with a rectangle again. The dimensions of this rectangle are 4 meters by 3 meters. So what is its area? Well, using our formula, we know that the area would be 3 meters times 4 meters, which is 12 meters squared. But now, if we were to cut this rectangle directly in half along a diagonal line from opposite corners, well, it forms 2 triangles. And because of each of these rectangles is exactly a triangle, that means that the area of either triangle must be exactly half of the other area of the triangle. We already calculated that the area of the entire rectangle is 12 meters squared. So the area of this triangle must be 6 meters squared. And the area of this triangle must be 6 meters squared since 6 is half of 12. So the formula for the area of a triangle should just be half of the rectangle. Does that mean area equals length times width? It should be area equals 1/2 of length times width? Yes, that's it. But with one important difference. Instead of L for length and W for width, we're going to use 2 different names for our triangle's dimensions. We're going to call them base and height. Here's why. The names length and width worked okay for this right triangle because a right triangle is exactly half of a rectangle. But those names don't work for the other kinds of triangles like acute triangles or obtuse triangles. Because how do you tell which side should be which? So for triangles, we do something different. First, we choose one of the 3 sides to be the base. It doesn't really matter which side we choose. And in a lot of math problems, the base will already be chosen for you. Now, once we decide which side the base is on, we imagine setting the triangle down on the ground so that its base is flat on the ground like this. Next, we find the highest point of the triangle, which is the vertex that's not touching the ground. From that point, we draw a line straight down to the ground. The line we draw must be perpendicular to the ground. The length of that line is called the height of the triangle, and some people call the height of a triangle altitude, which makes a lot of sense if you pretend that your triangle is a tiny little mountain. Sometimes the height line is inside the triangle, like an acute triangle, and sometimes it's outside the triangle like an obtuse triangle, and sometimes it lines up exactly with one of the triangle sides, like with right triangles. But no matter where it is, the formula for finding the area of any triangle is just the same. So, area equals 1/2 base times height. So, if we know those two measurements, which is the base and the height, we can just plug them into the formula to calculate the area. Well, at first, you might not see how the same formula could work for all three types of triangles. But watch this. Here's an acute triangle, and this box is 1/2 its base times its height. If we cut our triangle up, we can see that it fits perfectly inside that area. But wait, there's more. Here's an obtuse triangle with a box that's 1/2 its base times its height. Again, if we cut up the triangle, it fits perfectly inside the box. Now we can see how the formula area equals 1/2 base times height works for any kind of triangle. Alright, so we all know all the basics of the area. We know that area is a two-dimensional quantity that we measure in square units. We've also learned that the formula for calculating the area of any square or rectangle, area equals length times width. And we also learned the calculating area for the area of any triangle, which is area equals 1/2 of the base times a height. And that is all for our lesson for now.